An element is a pure substance, as you know, because it's on the right side of that branch. If it's on the right side, it must be a pure substance. It's a pure substance. That cannot be separated even by chemical means. So we know it can't be separated by physical means because it's on the right side of the graph, the right side of the chart. But an element is something that can't even be separated by chemical means. It just is what it is forever and ever. That's all it is. There's a little bit more than, I'll say greater than, 90 elements on Earth, naturally occurring. 90 elements on Earth. The most common ones are things like carbon and hydrogen and nitrogen. Copper, gold, silver. Now, just to be clear, if it's on the periodic table, if it's a box here, yeah, those are examples. The definition was a pure substance that cannot be separated even by chemical means. The diagram is there are over 90 elements on Earth. Over 90 elements on Earth. So the periodic table is a bunch of these boxes. A bunch of the boxes lined up. You remember that from physical science. You don't have to, but I would if I were you. And then you have an uppercase letter, and then a lowercase letter. Yeah. Elements are written as an uppercase letter, then a lowercase letter. For example, AA or BB, something like that. There's some of them are just one letter, like nitrogen or oxygen. But if it's a box on the periodic table, that means it's an element. If it's one of these boxes, that's what an element is. Just to be clear. Yeah. So whether it has two letters or one letter, if it's in a box, it's an element. And you will always have access to your periodic table. During any sort of activity or lab or test or quiz, you'll always be able to use a periodic table. So if you ever need to know if something is an element, just look and see if it's in a box. Then it's an element. But sometimes you'll see something that's more than one box. For example, if it says NOC, that's 3 different boxes, so that's not an element. If it's just a single box on the periodic table, then it's an element.
Just a single letter box? What if it's double letters? It's BP.
That's still an element.
Okay.
Yeah.
So they're all elements.
Every box on a periodic table is an element, yes. But the difference is, if there's more than one, box, I will clarify. Yes, Jordan. Different periodic tables are colored differently. Usually the colors distinguish between metals and nonmetals and metalloids. But really every periodic table is a little bit different. All right, can I go to the next thing, guys? Now this is different from a compound. A compound is 2 or more different elements. Two or more different elements combined chemically. For example, H2O, water. H is an element and O is an element. So if you looked on a periodic table, there would be a box with H in it. So H is one element. There's also a box with an O in it on the periodic table. O is a different element. Alone, they are elements. But since they're combined together, since there's two or more, since in this formula there are two or more separate elements, there's an H and there's an O, that means it's a compound. So it's a compound if it has two or more elements, two or more different boxes.
What else has
If it's alone, it's just an element. Sugar has two in it. Sugar is C6H12O6. Did you guys do that in biology? Or salt, NaCl? NaCl is salt. C6H12O6,
Hey, she got a question.
that's sugar. Yeah, question?
Wait, so that just has two hydrogens and one oxygen.
Exactly. Yeah. Any questions on the distinction between element and compound? I know it can be a little bit confusing.
It's simple because an element is just like one letter, like one element. It's just like one of the classes on the periodic table, and a compound is two.
Exactly.
So it's either.
Wait, once we finish the notes.
We take lots of letters.
No, it can be two letters. For example, guys, this is a really interesting, Mariella asked a great question. She said, what if it's two letters? For example, the Na. It's still one element because it's one box on a periodic table. If I looked on a periodic table, there would be a box with Na in it, and there'd be a separate box with Cl in it. Some elements are one letter, like O or H, but some elements are two letters, like Na or Cl. But the second letter is always lowercase, that's how you know. So whether it only has one letter in it, like hydrogen or oxygen, or two letters, like sodium or chlorine, if it's only one of those things, it's an element. If there's two of them put together, it's a compound. Does that make sense?
Yes, sir.
But if it's two letters, they always do uppercase then lowercase to let you know that it's a two-letter element. All right, that makes sense?
Yes, sir.
All right. Okay, we just did compounds. Now let's talk about the periodic table just for a second. The periodic table of the elements. You've all seen it. But you need to know how it's organized so that you can properly read it. The periodic table, as you've seen, is just it's a grid. It's got a bunch of different boxes in it, and each individual box represents a single element, whether it's one letter or two letters. The only reason they use two letters is because they ran out of single letters. How many letters in the alphabet?
25.
Yeah, 26, but there's more than 26 elements. So the reason that they have two-letter ones is just because they ran out of letters. That's the only reason why. They're not trying to confuse you. Each column of the periodic table is called a group.
So you want us to write this?
Yes. Each column is called a group, and they're numbered. Group 1, Group 2, Group 3, Group 4. And the rows are called periods. Period 1, Period 2, Period 3, Period 4. You need to know that the columns are called groups, and the rows are called periods. It was invented by a man named Dmitri Mendeleev. Oops. It's a pretty name. Oops. There's a V on the end. Let me rewrite his last name, Mendeleev. Yeah, he's an important man. Dmitry Mendeleev.
What is that? Is that IHT?
ITRI, Dmitry.
No, over there.
Period. Invented. Oh no, I crossed that out. That was a misspelling. Invented by Dmitry Mendeleev. DMITRI. Dmitry. So now, why do you think he invented the periodic table? Why can't we just have a list? Why do they need to be in a table? It's to be organized, yeah. But they're not organized alphabetically. They're categorized. And how are they categorized? Atomic number. Yeah, think back to physical science.
That's what 2 years ago.
The reason why they're organized in a table is because the ones in the same groups have similar properties. So all the ones that act one way are in that group. All the ones that act a different way are in that group. A different way in that group. That group. That group. And that group. Yeah, those are a little bit more complicated. For now, just worry about, it's just like a calendar. Every Monday, when you have a calendar, you go Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Even though they're different. This Monday is the 1st, this Monday is the 8th, the next Monday is the 15th. But they're all Monday. And same with the next one, Tuesday. The first Tuesday might be the 5th, then the next one would be the 12th, then the next one would be the 19th, but they're all Tuesday. Same with these Wednesdays. They're different dates, but they're all Wednesday. They all suck because it's Wednesday. Same with Friday. They're different dates, but they're all Friday, so they all have a lot in common. All right? So they're organized so that the elements in the same group have the same properties. They all act the same way because they're in the same group. So let me write that down. So this is really important. I'm going to clear the slide and make a note. This is an important point. Elements in the same group have similar properties. And that is the whole purpose of the periodic table. To organize it by similar characteristics, just like a calendar. You good? Hmm? You guys are doing a great job of taking notes. I'm very impressed. This is how it is in college. You just kind of chill and the professor writes stuff and you write it down. So this is good practice. Except in college you have to do it for a much longer period of time. So this is really good practice. You guys are doing a great job. Well, yeah, but I don't do this for the whole hour and 30 minutes. Try not to. All right? The last thing we're going to write down for today is the law of definite proportions. This is about compounds.
What was that?
The law of definite proportions.
I saw a little glitch.
Yeah, that's not a
It was an alien landing. The law of definite proportions says that a compound is always composed of the same elements in the same proportion by mass. A compound is always composed of the same elements in the same proportion by mass. Now, just to give you an example, let's just say you have a huge bucket of water, a gigantic 10-gallon bucket of water. And then you also have a tiny little glass of water. In each container of water, you have the compound H2O. How do I know H2O is a compound?
It has an H and it has an O.
It's got two different elements. And they're both uppercase. H2O. In each of these containers, there's the same ratio of hydrogen to oxygen. There's 2 H's for every single O in the entire bucket. And in a small amount, there's 2 H's and an O, 2 H's and an O. So the proportion of H to O is the same in any amount that you have. The proportion never changes. You're always going to be a 2-to-1 ratio. So it basically is just saying that a compound is always going to be the same no matter where you look. It's going to have the same ratio of elements. Let's get some Jolly Ranchers out. Ooh, we got hands shooting up for this one. Which of the following is a compound? Gabe, what you think? A is the right answer. So this is important. Let's talk about it. Water is H2O.
We just did talk about it.
Neon is that. Steel is a combination of mercury plus iron
So what did that make it?
plus other things. But it's a mixture. It's not a compound. And crude oil is a bunch of different things. So water is a compound because it's got 2 elements combined together. Question number 2. Periods are blank on the periodic table. Are they rows, horizontal or vertical, diagonals? What is a period? Taylor, what you think? Period is horizontal rows. What do we call the vertical rows? Groups. And those are the ones that are all similar. Alright? Any questions? It's pretty basic stuff, right? Nothing too crazy. We will have a test next week. Again, I'm really proud of all the work that you're doing. This is great. You guys came in, you gave me 4 really good days. It's good work. It's either going to be on Wednesday or Thursday. I need to talk to Miss Babbitt and Miss Blake and see what they're doing. I'd like to do it on Thursday. I don't like doing tests on Fridays.
We like
because
your class, that's why we're good in it.
we're good. You like tests on Friday?
Nuh-uh.
If you had to vote Thursday or Friday, when would you rather have a test?
Thursday.
That's what I thought. Question, Mariella? All the definitions